Alright, hi, I'm starting a video again on some basics in art. So what you're going to want to do is take careful notes so you can study this. So here's what we're going to do today. We're going to talk a little bit about color theory and finger painting and crayons and shapes and, okay, are they gone? You listening? All right, here's the good stuff. We're not talking about any of that today. We're talking about art, but we're going to talk about art and science. You see, here's the secret. A lot of people think I teach just finger painting. You know better because you've had me in class. So, just like in class, we are going to get into some science today that deals with art. So, you don't have to be perfect at math. You don't have to be perfect at science. I have a little sip of water. Okay. To get into science and art. I have here today something I was playing around with last night for fun after talking to some students and what they might be interested in. And what I have here is like a mad scientist experiment. You see all this? You see this? You see this? This is art. And here's why it's art. So I have these aluminum plates here. Real boring pieces of aluminum. There's a lot of technical terms I could include in this, but I want to make it short enough that you have time to getting back to playing outside because it's a nice day out, or reading a book, or just being a kid or finishing other work. So I'm going to keep it pretty simple today. But I have some sheets of aluminum, and they're kind of really shiny. And I was wondering, like, you know, I kind of want to play with the patina. And the patina is how the surface of them look. So the surface of them is really shiny, really bright, but I know that metal can have different patinas and different looks to it. So I decided I would play with that. So I did a little research, and I remembered that there's ways to use electricity and acids and salts and current, yes, electricity, to do what's called acid etching. Now let me see. Maybe I left those plates inside, so if not, we'll just make some now. So if you see, I have these plates, and I've got lots of them, so we're going to use some of these as our control, or basically the plate we do nothing to, so we can compare our results to the finished product. And we are going to use a 9-volt battery, a little bit of wire, and 2 pieces of copper that I happen to have that I was doing some jewelry making with about a year ago. These were some scrap pieces, and I've already been using them, so it's already changing the surface quality of them. You can see it's kind of like a copper penny on this side and shiny, and on this side it's kind of like rose colored and frosted looking, and that's because it's acid etched. To acid etch the copper, I can basically create this solution, which is nothing more than, here I'll show you, white vinegar. It's a very weak acid, but it's still an acid, and table salt in a jar. And if you notice, I have one of these outside of the jar and one of these inside of the jar. Because when you have a battery and you have a positive on one side of it and a negative on the other, they want to even out. And all they need to do to even out is touch. And if they touch and connect and get a circuit, all that heavy part is going to kind of like even out. So it's kind of like a dam with a flood. It's got like holding all that water back, and if you release the valve, it's going to even out with the water below, and eventually it finds this equilibrium. So we're going to take this wire on this side with this piece of copper, and notice I'm holding it by the sheath of the wire because that's an insulator going around the wire, so I'm not coming in contact with any electricity. And I'm going to stick it into it, and almost immediately it starts to bubble. Do you see that? Can you see that? It's starting to bubble. And if I just set it just like that, it's going to bubble and fizz and fizz and fizz. And that's the electrical current doing its thing. Now the salt in this solution helps that current go a little bit faster and a little bit stronger. But I've got a good connection with my wires that it's really bubbling and fizzing. So you are watching the electrical current have an effect on the chemical materials here. Now what's happening is it's going to start to move not just the ions with those electrical charges in them, but it's also going to move ions of the copper. So, it's going to kind of make the copper flow through that liquid, and some of it will get kind of stuck in there. And what's going to happen is one of these pieces is going to get darker and pull up those copper ions, and the one's going to kind of get lighter as it gets etched by the acid. So acid etching is a really cool thing. I knew this would probably not work back here while that's etching away. I knew this probably would not work back here, but I figured I would try it anyhow. I have lemon juice with a plate in here because lemon juice is an acid. But I put this in overnight, so I'm going to go ahead and take a look. And because there's no electrical current on this, I'm just going to use a fork to fish this plate out. And you thought I was going to teach finger painting today. And I think I'm not going to see much of any result. See, no really result. This is an unedged piece with so like just a plain regular piece of aluminum we've done nothing to, and this one has nail polish on it as a resist. That way if it did etch it, I could take off that nail polish and you would see a difference. But I'm seeing no difference using my observation skills to see that it's going to make a difference. So I'm going to let that be and put the lemon juice aside. So I know that doesn't do anything. Now, you want to be very careful before you try anything. You actually want to make sure that there is precedence for somebody trying it if you mix things, because you don't want to mix things that'll make something toxic, because that can happen. And just like any type of art I have you do, always, always, always ask a parent first. Now, this plate is in a solution of, again, vinegar and salt. This is vinegar and salt, but no current. And so without the current, let's see, no difference whatsoever. Okay. Huh. Well, let's take this out. Ooh, look at that. That's our side's already darker. And this side is lighter. Do you see the difference? And that's what electricity does. With a weak acid and a salt solution, you can create acid etching. You're like, well, is that really etching? Yes, it's etching this piece here. Okay? So we can see what we can do about acid etching one of these pieces that didn't have any result, because there's no change to them. Since there's no change to them, I'm going to wipe them off, so that way I can't say the lemon juice is affecting it or the other jar. And sometimes I'll hear people that study art, even at the college level, say, oh, I'm experimenting. I go, what do you mean by that? They go, oh, I'm just trying a bunch of different things. And I always say, well, did you write it down, or do you know which one's which? No. If you had to do this all over again, could you really control the result and make it come out the same? No. Well, then it's not an experiment. If you're going to use scientific process in art, you have to know that you are repeating the same steps to get the result you want. So we have this plate here with a little bit of nail polish put on, and I'm going to take one of these out, and I'm going to look. So that side I just pulled out is connected to the negative. That means they're flowing this way. So it's coming off of this piece and going onto that one. This side is the positive. So the electricity is going this way. And the cool thing is, you know it's working when you hold your battery. It's hot. So again, this is something I don't recommend you necessarily try at home, but if you do, ask a parent to help you out, just like you would with any project I have you do. You do not have to do this. This is not an assignment. This is just something fun that, as an artist, I play around with, and I want to show you that process, because the process that artists use does involve other subjects. It involves math. It involves science. It involves a little bit of all different things to study. But other than just writing it down and filling out an answer, oh, look at that. Some of the copper's even getting onto my skin. It applies it in a way, and since I'm not touching that, I don't have to worry about the current. It's not going to do anything. Now, if I put my finger in here, I would complete the circuit. We don't want that. So I'm going to leave this like this, and I'm actually going to take this off. This is a busted up wire from a charger that I had that was not working, so I figured I would use it for this. Okay, there we go. And now we got to see, if I go to dangle this in, it's going to, oops, well, that's not going to happen because you see my wire popped off. This is how you know I'm not a big production studio. I don't have assistants like Bill Nye. I don't have a magic school bus. I just got tenacity. All right, so here we go. Ready? And we are in. So I don't know if we have a good connection this time. I'll know when we have bubbles. So we have some bubbles, and oh, it's already getting darker. Look at that. It's already getting a copper tinge to it. And there's bubbles starting to come up. Now, like I said, I'm experimenting. I'm playing around with this and learning about it just as much, and it's kind of jogging my memory of things I learned in middle school about science. So right now I'm depositing the copper ions, but I don't think they're going to stick, because from what I know about aluminum is the copper doesn't really want to fully bond to it. There's certain metals it just doesn't want to work with. So it might be on there, but I'm willing to bet it will wipe off. Now, if I were to take this piece and put it on this side instead, or switch the connection so that way this was, because this is the, positive. If I made the plate the positive and the copper the negative, it might etch it a little faster and give me a different result entirely. So I might try that. So here we go. See all that copper deposited on? I don't know if you can see that or not. I'll take it off because it's disconnected and you can see. Pretty cool, huh? See all that copper? So science! Science is cool. But watch, I'm going to wipe this, and I'm willing to bet it comes right off. Oh my goodness, yeah, it comes right off because it's not fully bonded. It's trying to transfer, but the aluminum's going, nope, 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 you can't stick to me, because of the type of metal that aluminum is. Now, there are other metals out there that you can put in that would work, but I want to try switching sides. So I'm going to do that. So all I'm going to do is leave that one there. And, oops, eye's a little itchy. I'm going to untape this a little bit. I already have some pre-ripped pieces of tape, so if this tape curls up, I can be ready to go. And I'm going to switcheroo. So, if that's the positive, I now want to tape this to the negative. So I look at my battery, there's a little negative sign, just like plus and minus, just like in math. And I gotta be careful not to touch both leads of the battery at the same time. So I'm gonna touch that, tape it down. Normally I would use electrical tape, but in a pinch I'm using duct tape because it works. As long as I keep these two separate, I'm safe to do that. Just for now. I'm gonna take this side and tape it to here. Whoops. And I'm making sure to get that metal filament, because there's a lot of other stuff inside of this wire that's not really conductive. It's just filler for the wire. Alright. So I got those taped on. So that means that this is going to be the positive instead of the negative like it just was, and this is going to be the negative. Did I get that right? Yes, this is the positive. So it's got more connections. Or I'm sorry, more positively charged ions, and they don't quite, it's almost like they don't quite fit, and they're trying to get off the elevator. There's too many people. So now we're going to put it in, and the bubbles should go to the other side. See how they're going to the copper? The copper's now bubbling on the other side, and that's because I switched the direction of the current right now. Now the battery is still flowing the same way. It's just which ends of the battery did I connect. So this should etch this aluminum piece. And by etch, I mean it kind of roughs up the surface and makes it kind of darkish looking, because all those little pits and grooves give it a little bit more shadows. But where it can't etch is where I put that nail polish. That's why it's a resist. Just like when you color with crayons in elementary school and use watercolor over it, and it pushes the water off the wax of the crayon, and it won't allow that pigment to deposit. Well, that's kind of what this is doing. That nail polish is resisting the acid that's etching into the metal. Oh my goodness, look at it bubble away. Bubble, bubble, bubble. So while that's bubbling, I'll just let you know, if you have any requests or any weird questions, even if it's like, hey, how does this relate to art? I will happily share videos or make videos and explain how that works, because, hey, I'd rather you be entertained and learn something that you're curious about than me go on about something that you're not. So, that being said, I made some bread this morning, and I'll be making another baking video tomorrow to put out. I know we have a video on butter that was made. Let's see how we're doing. Ooh, look at that. Oh, that's definitely etching. See those little stripy lines? Yeah, that's etching away. Put that right back in. So again, I'm controlling the process by understanding what's happening. If I didn't understand the science, I wouldn't even think to do this. I wouldn't even think to do this. I might go, oh, well, I'll just put spray paint on it. That's boring. Spray paint washes off. What I'm doing is science. And science means you kind of learn as you go, and you learn just as much from your mistakes as you do from your successes. As long as you can repeat it or adjust things to get the result you want, that's you're applying science in that way. And that's what artists have to do. I've had to do that for pottery, for glaze making, and for firing pieces, and seeing what colors I get and how to get them exactly how I want and to lay where I want and melt how I like. So it takes practice, it takes observation skills, it takes controlling your variables and recording that data. Okay, let's see what we got. Woo-wee! Now let's see if this wipes off. Let's see if this wipes off. So it's disconnected because it's out of the solution, so I can handle it safely. I'll put this back in here. Where did my towel go? There it is. It fell down. Oh my goodness. So it's wiping off, but I think it's etching away at the piece. Because if I compare the two, it's a real subtle thing. This is a lot more dull than this when I look at it in my hands. It's got this stripy look to it. So what I'm going to do is leave this in for a little bit. I'm going to keep an eye on my battery, make sure it doesn't get too hot. And we'll see if we can actually etch it. And if I have results, I'll post them in class tomorrow. All right, y'all. Oh, yeah, finish up your finger painting assignment. Good job. Let's see. And I can't turn off the camera because it's too sunny out. Look at that. Mrs. K has a blooper in class. Random singing is awkward because it's like your mom singing. Have a good day.